My name is Yonatan Dolan, and I'm the Business Development Manager for Big Data and Analytics at AWS in Israel. With me here today is Darren Brien, a Senior Solution Architect at DoIT International for this joint webinar between DoIT International and AWS. And today we'd like to share with you how you can build a secure data lake on AWS in just a few days. You probably all recognize the person in this image. This is Albert Einstein in an image taken while he was teaching at the Zurich University back in 1910. Towards the end of the semester, Einstein was walking around with one of his associates, and the associate asked Professor Einstein what he's planning for the physics exam at the end of the semester for his students. Einstein replied that he's probably going to use the same physics exam he used last year. The associate, shocked with the answer, replied, "But if you use the same questions, Professor Einstein, wouldn't all the students easily get an A?" Professor Einstein looked at his associate and replied, "The questions are the same, but actually the answers have changed." And I think the story has a lot of resemblance to what we're seeing in the world today. We have new technologies, new capabilities, new tools that didn't exist just a while ago, but the questions, those really haven't changed. Organizations are still looking at how to reduce their cost, how to increase their productivity, both for people and the organization in general, how to introduce new products and services to the market, and obviously how to make decisions better and faster. One thing that is very different today is around data. Everything today revolves around data. And I'm sure most of you have heard the phrase, data is the new oil. But the less known part of this phrase is that data, like oil, if unrefined, cannot really be used. In order to refine your data, we probably need to start understanding the different data sources. Every data pipeline starts with your data sources, and those today are much more diverse and come in more sizes, types, and velocity than ever before. Streaming data can come from sensors or cameras. Batch data can arrive hourly or daily. Data can be structured, such as data originating from a relational database, or it could be unstructured, such as tweets and emails. It can come from external sources or from one of your systems within AWS. This data can hold tremendous opportunities and can generate significant advantage for those organizations who are able to collect it, store it, refine it, and extract insights from it. However, all this data can also pose some challenges. Let's look at some of those challenges. The first one is probably data visibility. In the past, this challenge was less significant. Organizations used to generate, store, and analyze small quantities of data. However, these days, organizations are analyzing only a fraction of the data being generated. And that happens from various reasons, such as lack of tools, knowledge, or expertise. Data usage has evolved, and today there are many more data consumers, from analysts who are evaluating historical data to different applications which are consuming the data via APIs, and all the way to data scientists who are looking to predict future behavior using machine learning on top of tools such as notebooks. Each of these personas are using the data differently, and it poses challenges to the underlying infrastructure. It's fair to say that people want access to all data all the time and basically have no limitations. But these challenges also have hold a great opportunity. Let's look at how legacy system looks like. In legacy systems, we used to connect the various systems, our CRM, our transactional databases, to a massive data warehouse. The data warehouse would allow us to run our business intelligence tools on top of it. This method is characterized by several things that are worth pointing out. First and foremost, it requires the data to be structured and relational. Semi-structured data such as JSONs is less suited for it, and unstructured data such as images and videos were just a no-go for a data warehouse. The second thing is schema on write. Ingesting data into a data warehouse requires an ETL process which takes time. It has implications on data freshness, and schema changes often require significant effort and take time. The third characteristic of a data warehouse is that it supports querying using SQL. However, it is less optimized for machine learning or deep learning, which usually require much higher throughputs. Data warehouses are not cheap. They often coupled compute and storage, and organizations had to ask themselves what they want to keep, what to purge, perhaps perform various aggregations, but all of those decisions had implication on future analysis. A data lake tries to provide an answer to these caveats. Let's see how it works. First of all, it's important for me to emphasize that the data lake architecture is not intended to replace the data warehouse, but rather complement it and extend it and allow new ways to store and analyze data. A data lake allows us various things. First of all, we can save all our data at its raw format, no predefined schemas. The schema is only used on read. This can save us the need for complex ETLs, allows higher freshness of the data, and requires less maintenance. As we store huge amounts of data, but not necessarily all of the data would be analyzed, we'd like to separate between compute layer and our storage layer. This would save us the need to increase our compute when we have a lot of data. It can allow different engines to consume the data in different ways. And eventually, it enables us to be very agile and adopt new technologies and new tools for future cases. On AWS, most of our customers use S3 as the storage foundation of their data lake. It provides various capabilities, which makes it ideal for such usage. First of all, there are many ways to ingest and bring data into S3, from batch capabilities such as Snowball to streaming services such as Kinesis. S3 provides unmatched durability and availability, as well as infinitely scalable storage at a very low cost. It has a wide range of security, audit, and compliance mechanism to allow you complete tracking and control of your data. And lastly, S3 as a data lake integrates with many big data tools, such as EMR, to apply machine learning and utilize multiple clusters on the same data that you're storing on S3. We have tens of thousands of customers across all industries who are running their data lakes on AWS. However, manually setting up a data lake can be time-consuming, complicated, and requires a lot of manual processes. And with that, I'd like to hand it over to Darren, who would demonstrate how you can use AWS Lake Formation to build a secure data lake on AWS in just a matter of days.
Thanks, Yonatan, and thanks for having me here today. I'm Darren Brien. I'm a senior cloud architect at DoIT International in London, and I help our customers get the most out of our data, helping them build machine learning and data pipelines. I'd like to introduce the company that I work for, which is DoIT International. We're a cloud consultancy working with you to maximize what your cloud can do. We're a growing team of 100 employees across the globe, about 100 engineers. We're an AWS partner and can help you with cost optimization and architecture on AWS and other clouds. Our support is 100% in-house. You can see our support stats on doitinternational.com/stats, and we're really proud of our customer support, so go take a look. We're currently hiring engineers in Germany and France, so if you're watching from there, please check us out. At DoIT, we're able to offer all of these services at zero cost and for zero lock-in. We ask you to move your billing accounts over to DoIT, pay through us, and customers typically sign a 30-day rolling contract for access to all of our tools and support. So with the introductions over, I want to talk about our agenda today and motivate, as Yonatan has done, why building a data lake is a good idea. I'm going to talk a little bit about what tools AWS offers to work with your data lake, how Lake Formation fits in to secure your data lake, and develop our understanding using a motivating example. And at the end, we'll do a demo using Lake Formation to permission a user for a data set, which we can query using AWS Athena and visualize in Amazon QuickSight. So when I work with customers, I always think it's helpful to place new tools in the context of their usage. And I want to motivate an example question our business may have, which we can build up and show how we can build up an application to make answering that question possible. I'm hoping you'll be able to draw some commonalities with this example in your systems, and hopefully the kinds of questions that your businesses have. Analytics is about providing insight. That's our starting point, and ideally we want answers fast. So the question becomes how to use the different AWS tools to reach that insight quicker than we otherwise would have done. And the tools are a means to an end, and so it's really important to justify each of their usages. So I'm starting off with a question. Imagine you're on Westminster Bridge next to the Houses of Parliament and have a think about this question. We're dealing with a lot of uncertainty. We don't have all the information to condition our guess. We don't know what day of the week we're asking about, what period of the year. We don't have any data. So what's your number? Make a guess and write it down. And then think about how you could go about verifying this. Here's another question. And I think you'll agree that this is broader. We're asking over a longer period of time and over the entirety of London. You know, the centre, the residential areas, the financial district. It's also a relative measure. And so do we think this number is going up or going down over the last 3 months? And I'm talking about where we are now at the 22nd of June. So what's your percentage change? Make a guess, write it down, and think about how we could go about verifying this. And as we work through some of the tools and approaches that AWS advocate for building your data lake, I want you to stay focused on our business objective and think about how these tools are helping us achieve that. So this is an approach that I came up with to answer the two previous questions on the two previous slides. We have access to a publicly available data set from Transport for London of traffic camera images. These images are taken at 5-minute intervals, pictures on Westminster Bridge, and 1,000 other cameras in the London Road network. So that's 12 pictures an hour, and if my maths is right, that's 288 a day, over 1,000 cameras. So we're talking about 250,000 images a day. And on the right-hand side, we've applied an object detection model to count interesting objects, cars, people, buses, and collect that data. So we're applying a machine learning technique to turn an unstructured data set, images, into a structured or semi-structured data set of just counts and objects at a location at a specific time. So this is a way that we could go about answering question 1. Obviously, our images are taken at a 5-minute lapse, and so we don't capture all of the traffic over the bridge. One way that we could address this shortcoming would be to spend a bit of time on Westminster Bridge, count the actual traffic that we observe, and look to scale up our object detection counts to account for that difference, effectively telling us how many traffic per hour we're missing. For question 2, we can apply this approach across all of the data over many months. We'll spend some time with this in QuickSight later. We've got data from March until the end of June. It's about 100 days of data, almost 30 million images. So to provide some intuition, for a 30 frame per second video, that's enough images for around 140 2-hour films. Now, you may have seen that we made some errors misclassifying a bus as a train on the previous slide. It's the new-ish Routemaster bus, which travel around London. They've got a sleek design, and so our object detection model has misclassified that. It's made an error. But if we assume that the errors that our detection model makes are random, then the percentage change in the traffic is still valid, and we can make that relative estimation of the changes in traffic and still, feel like our estimate is solid. And by taking this approach, accepting that we will make some errors, we're able to scale up to a level of counting that no human could ever achieve. And AWS provide the tools to give us that scale. So we're taking about 1 terabyte of unstructured image data. We're running this through a detection model and producing around 10 gigabytes of JSON detections. And later on, I'll show you how we can use tools like Amazon Athena to make that data into a Parquet format, which is highly structured and really efficient to query in a quick and cost-effective manner. So back to data lakes. And a data lake is your central repository to store all of your data, structured, semi-structured, and unstructured data. Think Parquet, JSON, and image data, binary blobs. And as we've said, data is the new oil. Businesses have a valuable resource in their data, but a challenge is you don't always know what questions your business may have in the future. If you collect and store everything, you're in the best possible position to address that uncertainty. So you don't need to make all your decisions about what to store now. Amazon have tiered storage levels on S3, and you can store a terabyte of data on S3 Glacier for as little at current prices as 40 cents a month. This is the Hoover Dam, and that's the Colorado River. Now don't worry, I checked a map, and upstream there is a lake. So at DoIT, we work with many customers who take this approach to storing petabytes of data per year. And they need something like the Hoover Dam, which can take such a huge amount of data. And despite agreement that data lakes are the right thing to build, it can still be a challenge to build a data lake, and building a data lake can be a significant investment of time. We want to scale like the Hoover Dam, but we don't want the time and infrastructure investment it took to build it. Customers agree that Amazon S3 is the tool to store all of that data with all of the guarantees it provides. It's cheap, durable, available, and effectively infinite. A nuance of this approach is using S3 allows us to separate out compute and storage, meaning we can easily scale horizontally and address a limitation of the traditional data warehouse, where scaling is typically vertical with bigger instances. We don't want to make several copies of our data to analyze it. We want to bring compute to our data and leverage the serverless tools which AWS provide, which we can scale up to work with our data without us having to provision them. So we've talked about volume, which is often in the petabytes, variety, structured, unstructured. As Yonatan has mentioned, another limitation of the data warehouse is it's not heterogeneous. Only really structured data is supported. Using Amazon S3, we can store all kinds of data, and that's a real advantage. For velocity, we can think about things in a few different ways. So for our problem, we've got about 250,000 images a day. We've also got to factor in the growth that we're going to experience. And a lot of the customers that I work with at DoIT International are internet businesses and digital natives, and they can experience exponential growth over a few months. They need to pick a solution that's going to support them in that journey. I think we all have a lot of practical experience of what exponential growth means over the last few months. And you want to build your data lake somewhere that can tolerate order of magnitude shifts in your data size. S3 is that serverless tool. And there are other serverless tools like Glue, Athena, or Redshift Spectrum that can work with data of any size on Amazon S3 to perform your ETL, build your data catalog, and allow you to run queries and perform analytics. Of course, you've also got access to the other tools that Amazon provide, like EMR or Redshift, which you can use to examine your data, but these tools aren't serverless. Decoupling tools is really nice because it doesn't lock us into a single way of doing things. We avoid the Highlander prophecy, that can only be one. And I find that my customers prefer a serverless approach because they're only paying for what they use, and they have a variety of tools they can pick from to perform their task. So S3 can store all of our data. There are a myriad tools available to then work with and analyze that data. But organizations need to have oversight and control of their data and who can access it. If data is oil, they need to avoid any oil spills in our data lake, and they need to prevent data leaking out. This isn't always, although it is predominantly a security concern, it's often just good governance. There's high utility for an organization to have data managed centrally. If you're familiar with software development, you may be familiar with Conway's law, which says any organization that designs a system will produce a design whose structure is a copy of that organization's communication structure. Or if you have 4 teams working on a data pipeline, you'll end up with 4 data pipelines. Now, this isn't due to the bad intention of the teams and the lack of desire to collaborate. It's a path of least resistance. Lake Formation removes some of the impediments to make building a centrally managed data lake easier, so that you can avoid building several data ponds. So Lake Formation is a single place you can manage access and authorization of your data lake. It addresses key business risks of data loss, either accidentally or otherwise, and it protects your data from unauthorized access. That includes both internally, your employees, or externally. Lake Formation is a best-in-class offering which allows you to secure your data lake with very little overhead, using the tools that you're already familiar with. Think about how permissioning works in your organization currently. What's your process for providing access to data? Do you have audit logging of access and granting of permissions? Who's in charge of applying your data permissions consistently? Can you support self-provisioning? So different organizations have different requirements. And that can often be based on regulation in your industry. Some industries require compliance reporting, for example. These requirements are essential, but they're not functional. They're not helping us get to an answer to our question. Lake Formation helps you get out of your own way by providing a service to do all of this. And the service itself is free. You only pay for the services which Lake Formation is integrating with, for example, storage on S3 or compute on Glue and Athena. And because these are serverless services, I could build my data lake for much less than $100. So if you're building a data lake on AWS, avoid not invented here. Data lake security isn't part of your competitive advantage. I want to be counting traffic. And you can leverage Lake Formation to secure your data lake fast. In his book, The Lean Startup, Eric Ries talks about the build, measure, learn cycle. This is about building a product, running an experiment, taking measurements, and learning from those measurements to improve what you've built. And we can certainly apply this methodology to data analytics. And this is why building a data lake in days, it's not a cute slogan, it's a business imperative. At DoIT, if I can help my customers answer their business questions yesterday, we can focus on improving our answers today. And we want to iterate to climb the pyramid so that we can take data in S3, the traffic images, apply a deep neural network to do object detection and create some semi-structured information. We want to catalog that information centrally, combine it with other data and secure it, get to knowledge, and ultimately draw conclusions from the data to achieve wisdom. How has the traffic changed over the last few months? Another aspect to this is when you're building a data lake, it helps if you understand your data flow. So on the left, we have our production application collecting data. On the right, we've got our data lake where the data has been collected, cataloged, transformed, and analyzed. Now, if you spend much time with the data scientists in your team, they'll often talk about the data generating process. And so as data engineers, understanding how your data came into being can really inform your decisions about how to store and analyze it. The point being, don't just take the data from the green bucket on the right and stay ignorant of everything at the left. Make friends with your product developers and understand the production system. Once you have your raw data, you can then use these serverless tools to get insights. And Lake Formation is available to ensure the correct access is applied consistently across all of your data. The second perspective is the people perspective. Now, these columns are coarse-grained. The dividing lines will vary based on your organization, and you may have one person doing all of these jobs. But if you do, it's probably helpful to know which of these hats they're wearing at any one time, because the access that you have shouldn't be the same depending on the role that you're performing. And so now I want to show you the Lake Formation console and go through a demo. So this is the Lake Formation console, and this dashboard shows us a searchable audit trail of access and authorizations to data in our data lake. This is all stored in CloudTrail, addressing a key compliance requirement for many businesses. And of course, this 90-day number can be configured based on your needs. We've got a databases section, which tells us about the data that we have in our data lake. You can see we've got one here. It's a TfL transport for London. Inside our database, we've got tables. And here we can only see a subset. There are more tables than this available. And I want to show you how straightforward it is to permission a user for a data set using the Lake Formation. And so now if I refresh this view, we can see a third table's come into our permission structure. We have access now to the latitude and longitude of different traffic counts, which we previously didn't. Now I've made that change using the Data Lake Administrator role, which is a role that AWS advocate you create when you're building your data lake to start with. We'll talk more about that later. You've also got this data lake location section. Now, we've agreed that data lakes make sense on Amazon S3, and this is where you configure the storage locations for your data lake. We also have a set of blueprints, and these are templates which allow us to pull data from relational databases, our data warehouse perhaps, or even logs in CloudFormation. If you've done much work with Glue, you'll be familiar with crawlers. And because Lake Formation natively integrates with Glue, we can easily collect metadata like schema information on the datasets that we have on S3. Of course, if you need to do ETL, you've also got access to Glue jobs and a tight integration with that. It's worth mentioning that when you start using Lake Formation, there are two permissions models you can work with. By default, the Lake Formation model won't be applied, which means you'll be managing access in the traditional way via IAM. If you opt into the Lake Formation permission model, you can control access to your entire data lake in one place, and you'll get all the benefits of using this tool. AWS, as I mentioned, advocate the creation of a data lake administrator, controlling access to your data across your AWS account, and also a second role called a workflow role, which is like a service account. And this is the role which our Glue jobs are performed under. So when you run a crawler or an Athena query, the user is first checked for authorization by Lake Formation to ensure they're allowed to perform that operation. Lake Formation also supports federated permissions. That means that we're able to delegate permission or granting of permissions down to the right person. I'm going to show you how that might work. I'm going to grant permissions to, first of all, I'll show you the data set that I'm going to grant permissions to, and you'll see that I've got some permissions in this grantable column. So these are the permissions on the permissions column that I have to the different resources listed here. The grantable column is telling me which data sets I can provide access to people and service counts. So if I go into the grant section, having selected this dataset table, I can grant permission to my colleague, Jason. And because Lake Formation works at the column level, I'm able to actually provide access to just a specific subset of the columns that his role allows him, perhaps. So I'm actually going to exclude a column, the name column, which would allow a use case around preventing access to confidential information like credit card address, phone number information. And I can grant that permission to Jason. And you can now see Jason straight away is being provided access, but excluded access to the name column in this data set. So with this, we're not wasting time waiting for a centrally managed permission to be applied. We can delegate to the correct people, relying on our auditing in the console for a history of what's been accessed. If we jump to Amazon Athena, we can see that I've only got access to two data sets in this view at the moment. But as you'll remember, we recently permissioned us for another table. So if I hit refresh here, you can see that that's now been updated, and Athena can see the extra table that we've got access to. You can see here that we're taking the raw JSON data, the observations that we've produced, and this create table as command allows us to take raw JSON data and store it in an efficient Parquet format, a columnar format, which is optimized for speed of query. It's efficient fast, and it saves you cost because you only pay for the data that your query accesses. So if we take a look at this query, which is aggregating some of our observations across the different objects that we observe, we can see we've only scanned 87 megabytes of data. And we've had a response in less than 4 seconds. So by applying the right storage medium, using, in this instance, Apache Parquet as our storage format for our data that we're querying on our data lake, we're able to get really efficient, cost-effective solutions to querying a large amount of data. And obviously this would scale up through those orders of magnitude from this 1 gigabyte all the way up into the internet scale, petabyte scale data sets. Once we've built this data set with an efficient storage mechanism behind it in Athena, we can use a tool like Amazon QuickSight. Give access to QuickSight to that data, which we've done through the Lake Formation console, then not just maybe provide access to those single questions that we asked at the start of the presentation, but put something like a dashboard in the hands of our users to provide them access to answer many different questions that our data may be able to help us with. So we can see here how these traffic numbers have changed over the last 100 days. So you can see in the map section the counts of objects that have been observed over the last 100 days at different locations. In the bottom left, we've got a time series which is showing aggregations by day of the counts of different objects through time, starting from around the end of March until the end of June. In this next panel, we've got the hour by hour counts. So this isn't showing on the right-hand side all of the data that we can see here, but it allows us to really zoom in on the most recent data. And I'll show you a bit more of this in a second. So to answer our general question of how has traffic changed over time in London over the last 3 months, from March 2020 until around the end of June, we can see here at the start that if we look, we've got counts for all of the objects. But if we just take cars, which is the blue section, which dominates most of the data, we can see we observed, well, of course we could add all of these up, but for cars we observed 381,000 cars in the London area on the 3rd of April 2020. If we come more towards the more recent counts, we can see on the 19th of June, we observed 673,000 cars. Obviously, all the other objects as well, but it's easier just to focus on the one number for now. And so if you had written down around an 80% increase from March to June in that question, you'd be about right. We can also answer the first question we asked, that specific question. And if we filter it down, the data here to a single day, all of these visualizations will update to show us the counts and the information for the single day, the 10th of June that I just selected. You can see on the right-hand side here, just make it a bit clearer for you, that this is all of the hours of the day through the 10th of June. We can see all the different objects that we've observed across the whole of London. Now, to answer our business question, we want to get down to Westminster Bridge, and that's really straightforward. We can just zoom in here, we can see Westminster, it's just vanished. But if we pop down, we can find Westminster Bridge, and this is our camera from the original image. If I select that image, all of the data filters down to just this location. So we're now showing all objects that were detected at this location on the 10th of June for the entire day. We were interested in buses though, and so if we filter down to just the buses view, we finally get to our answer, and we can see that 8 buses passed between around 9 o'clock till 10 o'clock on this particular day. And so we've taken a very broad data set. We've been able to answer 2 different perspective questions, one very broad, one very narrow. We've been able to drill down and answer both of them. And we've achieved a lot of velocity here by just using the tools available that AWS provide to manage your data lake. I'll just clear these filters down so you can take another look at the data set in all of its glory. And so what are the lessons here that I'd encourage you to take away? Well, firstly, prefer the Lake Formation permissions model, and I direct you to the Lake Formation documentation to really make sure that you're going through those steps in the right way, creating that data lake administrator user and that workflow role user that's more like your service account for performing your crawling, ETL, those kinds of things. If you're migrating with an existing set of glue jobs, it's even more important that you consult this documentation to ensure a zero downtime. And that's because as we change the permission model, you're going to make Lake Formation the single place to manage all of your permissions. And there's a process that's well documented on the AWS instructions for Lake Formation to make sure you do that in the right way. We also talked about getting to know your data flow. If you want to move fast, understanding your production system is really going to help you. Identify the actors in your organization and scope out their roles. Think about what those access policies should be and who are the right people to be providing access to different data sets. Consider that you might be working in different regions and different competency areas and with different heterogeneous data sets. And so the people that really understand those data sets may be the best people to be permissioning them. Lake Formation allows that federated permissioning model, which is going to make it really straightforward for you to move quickly in providing access to the right people. And you can build buy-in with your teams for why these steps make sense. You can direct them to this webinar and other AWS resources to sort of explain why these tools are useful. And so finally, I just want to say, I hope that's demonstrated that you can build a secure data lake in just a matter of days on AWS. On behalf of DoIT International, I want to thank Yonatan and AWS for inviting me to this talk. Please go to the DoIT International website and check out our statistics for our support and model. And thank you very much for attending today.
Thank you, Darren. That was very interesting. I'm sure the crowd learned a lot. Thank you for joining us for this joint webinar between AWS and DoIT International. And we encourage you, everyone that watched the webinar, to try experimenting, start playing with data and the data lake, and get help from DoIT International or the AWS team. Thank you very much.